Okay, good afternoon. Today we are going to start the topic examples of IUPAC nomenclature of coordination compounds. In last 3 lectures, we saw the different rules to giving the nomenclature of inorganic coordination complexes or coordination compounds. So we can use this rule according to condition which is present in complex. So the rule, which rule is applicable or which is not, it depends on their conditions which are present in given compound. So here we are going to start. So we follow all the rules. So it is very interesting to giving the name for the unknown compound which is unknown to you. So we are going to solve one by one. The first example is this is given to you: CO, NH3 thrice, NO2, Cl, Cn. Okay, and the question asked in October 2013. Okay, so look at the example. It is neutral because there is nothing cation or anion is present outside the square bracket. Complex is neutral, so we directly start the name of complex compound from complex part, and this is the complex part. And you know, in complex we start the name from ligands. Okay, so here the 4 types of ligand: NH3, NO2, Cl and Cn. First identify their nature. Is it negative, positive or neutral? NH3 is the neutral because containing lone pair. NO2 minus, so negative ligand. Cl minus, negative ligand. Cn minus, again negative ligand. So here 3 negative ligands. So we start the name from negative ligands, and in negative ligands we use the alphabetical order. So alphabetically in negative ligands, here is the cyano, here is the chloro, here is the nitro. So cyano and chloro both are letter is C. So chloro. So you can write cyano, which is come first. CC common, then we go to on next word. Here is the H, here is the Y. So chloro come first. So we should start from chloro. So chloro. Then cyano, then nitro. So negative ligand finish here. Then come on neutral ligand. There is a NH3 means amine. But how many amines? 3 amines. So here a need of prefix. And for 3 we use the tri as a prefix. So tri, amine, and at the end there is a name of the metal. So it is a neutral, so there is no change in name of metal. So cobalt. Then write the oxidation state. So what is oxidation state? So here is a 0 charge, so we can balance 0. Cyanide shows -1 plus, Cl shows -1 plus, NO2 shows -1 plus, NH3 shows 0 plus X. We will consider as a X. So overall X is X plus, we add all 3 together, X plus minus 3 is equal to 0, then X is equal to plus 3. So here write the oxidation state 3. Write the oxidation state 3. Nomenclature दिसतंय का तुम्हाला? का अजून मोठं लिहू नाव? एकानेच कमेंट करा. जे मी नॉमेनक्लेचर जे नेम लिहिलं आहे ते आयडेंटिफाय होते, दिसतंय तुम्हाला का अजून हँडरायटिंग मोठी करू नॉमेनक्लेचरची? ओके ओके, ठीक आहे, थोडे इन्क्रीज करतो मी नेक्स्ट टाइम. सो इट इज द फर्स्ट एक्झाम्पल. सेकंड एक्झाम्पल इज, इट इज व्हेरी सिम्पल. PT NH3 twice Cl2. Okay, so again it is a neutral complex because no cation anion present outside of the complex. So in a complex, we start name from ligand first. Here two ligands, NH3 and Cl. NH3 is a neutral, Cl is negative, so we start from negative. But here how many Cl? 2 Cl. So here again need of prefix. So for 2 we use the di is the prefix. So dichloro. Then again there is a 2 for di, there is a amine. So diamine platinum. Okay, and calculate oxidation state. Here is a 0. So each Cl shows -1. So here is a -2 plus, amines are 0. So X will be considered for the platinum. So X plus -2 is equal to 0. That means X will be plus 2. X will be plus 2. Okay. Third example is CrH2O6Cl3. So here coordination compound is ionic, and in that complex part is cationic because anion present outside of the complex. So that time we start the name from complex. Cationic part means from complex. In a complex we start from name of ligand. So who is ligand here? H2O. How many ligand? 6. So again we use the prefix hexa for H2O. And what is the name of H2O? There is a O. It is a O. So hexa O. Then cationic complex. So no change in name of metal. So chromium remains chromium. Then oxidation state. So here what is the oxidation state? So you can directly consider here 0 or you can separate out the charges. But this is the best method. So is the 0. So what is the charge of Cl? Cl shows -1. So -3 here plus 0 from water, X for Cr. So X plus -3 is equal to 0. That means X is plus 3. So oxidation state is 3. And here is a Cl. Cl means it is an anion. We can represent as a chloride, not a trichloride. It's just a chloride. Okay. So it is the third example. Fourth one. Okay. First, look at neutral compound. So, identify how many types of ligand? 3 types of ligand. NH3, NO2, but it is represented as a ONO, and here is the NO3 is the nitrate. Okay, so nitrato, okay, it is a nitrate. NO2 is the nitrito group. Okay, NH3 is the amine, and CO means it is here is a cobalt. So here is a negative in nature. These are also negative in nature. I think there is some mistake. Huh? Okay, sorry. This is outside of the box. Okay. So here is the nitro group, but ONO is the nitrito group. Amine, so coordination number is 6. So complex is cationic, that means we should be start name from complex part. In complex part there is a neutral ligand, there is a negative ligand. So negative ligand write first. So here nitrito आणि NO2 दिलेला असता तर आपण नायट्रो ग्रुप म्हटलं असतं त्याला नायट्रिटो. बट हेअर oxygen at the side of cobalt means the point of attachment is O. Oxygen is attached. Then okay, here is the nitrito is finished. Then NH3, how many NH3? 5. So penta amine, penta, amine, cobalt. What is oxidation state? So if you directly consider 0, NO2 minus 1, so minus 1 minus 1 minus 2 plus, here is a minus 1, 0 plus x. ओके, आणि हे तुम्हाला स्ट्रक्चर्स माहिती असते तर किती निगेटिव्ह चार्ज हे माहिती असतो, त्याच्यामुळे तुम्हाला चार्ज पण कळेल. सो x इज इक्वल टू plus minus 1 minus 2 minus 3, so x plus minus 3 is equal to 0, so x is plus 3 आणि chromium mostly plus 3 oxidation state दाखवतो, and at the end there is a nitrate, at the end there is a nitrate. Okay, fifth example is in given example, again complex is cationic because anion present outside the complex. So if complex is cationic, then we start name from cationic part, means from this part. In that we should start the name from ligands. In ligand there is a neutral ligand, there is a negative ligand. So we start from negative ligand first. So which is the negative ligand? Here is the sulfate group and we call it sulfato. So you can write sulfato. Then how many? 5. So here is the penta, amine, then cobalt. Okay, so what is the oxidation state? Here you consider 0, minus 1 plus SO4 shows minus 2, here it will be 0, there is the x. So x plus 0 plus minus 2 plus minus 1 means x plus minus 3 is equal to 0, that means x will be plus 3, so oxidation state is 3. And at the end there is a Br, means bromide. There is a bromide. 6. CrEn2Cl3. Okay, CrEn2Cl3. En means ethylene diamine. It is a wrong given in book, I think. It just write as a this way. Cl3 outside of the box, because here is the if the coordination number is 6, it is a bidentate, so 3 into 2 is the 6, so Cl3 outside of the complex. Okay, so here it is a bidentate, the name of ligand is, so first of all, see the complex is cationic, so we start the name from cationic part, so this part. In that we should be start from ligand. Here is the ligand is ethylene diamine, and ethylene diamine is neutral, so only one is present, that's why there is no need of order negative, positive or neutral, because only one of the type of ligand is here. So ethylene diamine itself has a prefix diword, so we can replace we can use the different kind of prefixes for such type of ligands. So here for 3, generally we 3 is the tri, but for special or the different kind of ligands we use 3 as a tris. Okay, so here tris, and write the name of ligand in a bracket. So what is the name? Ethylene diamine. So here use single M, and for NH3 use double M. Ethylene diamine, then write complex is cationic, then chromium. What is oxidation state? Here is a 0, each Cl shows minus 1, so here is a minus 3. Ethylene diamine is neutral for 0, and chromium consider as a x. So x plus minus 3 is equal to 0, that means x is equal to plus 3. So oxidation state is 3. And at the end there is a Cl, means chloride. Is the chloride. So there are 6 examples which is on the board. Okay, 8 number. This is given in book, but actually problem is wrong. It is a bridging complex because 2 cobalts are given, between that the ligand is mentioned is NH2, but here only single NH2 is mentioned. That means there is only one ligand. It is impossible because to make a such type of bridge, we need here 2 ligands. Okay, so but here only NH2 is given, so I just change is here. I make a change. And outside of the complex nothing is given, so it will be wrong, but okay, we will try to solve it. आपण प्रॉब्लेम तयार करून घेऊ, आपला स्वतःचा तयार करूया. We will consider here 2 because 2 bridging ligands must be required to make a bridge, and here you can consider here sulfate, twice sulfate. Okay, this is the actual example, but there is a printing mistake or there is a error. Okay, how to solve it? If it is a bridging and you clearly seen there is a 2 metals are given, means complex is binuclear, it is a bridging complex. So here you can draw in a different way. So you can draw as okay, so both are same. And you know what is the rule? If the bridging complex is given, that time we start the name of the complex from bridging part. Okay, so here bridging part is present, anion is there, so complex is cationic. So that's why we start from cation first. In cation, the nature of ligand is 2 types of ligand. There is a bridging and normal ligand. So in any condition, it is a negative. What happen in normal ligands? Which type of ligand present here? Don't. This is not important. Important is bridging first. So write the name of bridging ligand first. Here 2NH2. So for that we use di word. NH2 means amide. It is a amido. So before the name of this, we can use mu word, mu symbol, mu. How many? There are 2. What is the name? Amido. Then come on normal ligands. Okay, how many ligands here? 5 plus 5, 10. So 5 plus 5, 10. It is again wrong because here the valency 5 plus 6, 7. So valency is wrong. Valency काय होणार आहे? Wrong होणार आहे. कारण की valency 7 होते. So we expect here 4. इथे किती असायला पाहिजे? 4. कारण की coordination complex मध्ये हे जे आहे यांची 6 coordinations आहे. So 4 plus 4 octaamino, octaamine. Then there is a how many cobalt? 2. So dicobalt. And what is the oxidation state? Sulfate. So here is the sulfate. So we are going to balance 0, minus 4, minus 2, minus 4, minus 4, plus 0 for these 2, minus 2 because each shows minus 1, and here consider 2x for both the cobalt. So 2x plus this minus 2 and minus 4, minus 6. So 2x plus minus 6 is equal to 0. So 2x is equal to plus 6. So x is equal to 3. So oxidation state is 3. So the given compound in a exercise is wrong आणि ते wrongच दिलेलं आहे. Next one, K4FeCN6. So here the compound is ionic, but complex is anionic. The complex is anionic complex. So we start the name from cationic part. Who is cation here? Potassium. So K means potassium. So we start from potassium. So cation is finished. Don't use prefix for cation and anion which is present outside of the complex. So just write their name. So potassium is there. Then come on complex part. So in complex part the metal and the ligand is present. The ligand which is present here is the cyanide. That means it is the cyano group, and how many? There are 6. So here hexa cyano. So then write the name of metal. But if complex is anionic, we can change the name of metal, use or adding the ate, or in some cases we use Latin words. So Fe is iron in normal condition, but when the complex is anionic, Fe used as a ferrous and it is add ate, so it is a ferrate. It is the ferrate, very important. Then oxidation state. What is oxidation state? Finally you can consider 0. Here is the cation. It has +1 charge because it is an alkali metal. So +4 charge is here. Plus, if we consider if for Fex, Cn shows -1, so here is a -6. So +4 plus x plus -6 is equal to 0. That means here x is equal to +2. X is equal to +2, and here is the second. So second is the oxidation state. We take one more example and then stop today. We will continue remaining example in next lecture. Okay, so look at here. It is the another example. So overall compound is ionic, and here the complex part is cationic. Complex part is cationic. So we start the name from cationic part. So in cationic part there are two types of ligand. One is NH3, another is ethylene diamine. Both are neutral. So if both are neutral, we prefer the alphabetical order. So alphabetically ethylene diamine amine group come first because A, and ethylene means it is a E. So we start the name from amine. How many amines? 4 amines. 4 for 4 we use tetra amine. Okay, so here is the finished. Then for ethylene diamine, it is a different kind of ligand because in its name itself has a prefix is the di. That's why we use the different prefix. But here is only single ethylene diamine, so there is no need of prefix because prefix use only more than one ligand is present. So for ethylene diamine there is no need of prefixes, so you just write ethylene diamine, but in a square, in a bracket, always mention in a bracket. So ethylene diamine, then here is the platinum oxidation state. Now after N there is a sulfate. What is oxidation state? Here you consider 0. Sulfate shows -2. Ethylene diamine is 0. NH3 also 0. If we consider the oxidation state of platinum is X. So X plus -2 is equal to 0 means X is equal to +2. So second is the oxidation state. So these are the example. You solve remaining example, today try today, and if you have any difficulty, okay, you send your difficulties on group. Okay, so today we stop here. We will discuss the remaining examples in next lecture.